final session of the workshop. So we're gonna have a closing plenary. Myself and Justin are gonna panel this session or moderate this session. We've got 6 esteemed colleagues. Kind of the idea for this last session, I mean, it in some ways sort of wrap things up, but also talk about what's next, right? So that's what we had planned for the session. So we're going to have our colleagues here on the panel. You might notice we sort of have it split in some ways, where we have 3 users of forecasts and 3 developers of forecasts. David, you kind of said you can kind of be a hybrid of those, but we're going to try to, one of the things that I think this workshop has done over the last many years is try to make sure that we're each hearing from each other. And, of course, we heard about so many different things throughout the conference, but what are some other ways that we can help educate and communicate with each other and learn about what's coming, and how do we use that to make improvements, either to the types of forecast products that we're developing, or the types of enhancements or new applications that we can use those forecasts for within power system operations and planning and markets. So one quick disclaimer is that for specific reasons, I was in that room all workshop.
And I was in this one,
and Justin was in this room all workshop. So
that was not intended.
So do I know what was discussed here over the last 2 days in this room? No. And I'm looking forward to hearing that. We had some really good discussions in the other room about, how capacity markets are evolving and the prices are getting higher. Does that mean, is that a bad thing, or is that just kind of emphasizing the need for capacity? We heard a lot about storage, both long duration and short duration storage, and whether new products and services are beneficial for those storage resources, or are they beneficial for the system operator, or maybe they're not beneficial for anyone. We also had some forecasting discussions in this room, but on different things. We had a good talk about how to forecast reserve requirements, and actually, understanding that maybe some of the types of methods, including AI applications, apply for what reserve requirements might be in the future, just like they could be used for weather forecasting, and price forecasting, and some of the different methods with price forecasting, and how that has evolved over time, and how that can be used in applications. So, one of the things I think we'll talk a little bit about this in this panel is all of those different types of forecasts, many of which use weather to drive them, but what are the other things that we can use? A lot of these different methods that we've been using, for the last many decades, and how to apply that to things beyond the weather, beyond the renewable forecasts. So that's kind of some of the things. We also had a great session this morning that got a little spicy to talk about technology models and what some of us have been thinking about and sort of breaking things down, and some of us also thinking about keeping things similar to what they are. But those are some really good discussions. Justin, what did you hear in this room?
So in this room, and first of all, I'd like to say I'm filling big shoes here, so I feel both honored and also a little overwhelmed. And I know that Matt's going to say a little bit about that. John was originally supposed to be chairing this session. So, but the themes that really were coming out, AI was very much the rose to prominence. AI really rose to prominence in the parallel sessions related to forecasting and overall use of meteorology. Other themes, though, were data centers, uncertainty and risk assessment certainly were topics that we discussed a lot. We especially combining all different weather effects together. So starting to get out of that silo of wind forecasting, solar forecasting, and load forecasting, and looking at the combined overall impacts also impacts to other parts of the system like transmission. We had some interesting talks about use of advanced measurements and forecasting techniques for doing dynamic line ratings. One of the things that we really kind of missed, I think, was the impact of wildfire, which I think is going to become an increasing issue with climate change. I think that's where we're seeing the impacts of climate change the most on the grid. We did invite somebody to do that, and unfortunately they were unable to come. Kind of going back a little bit, advancements in new areas to squeeze out those efficiencies and lower overall risk. I kind of want to talk a little bit more about the AI side. We are clearly seeing improvements in skill and kind of sharpness of forecasts due to AI methodologies. One of the questions I have, and for everybody here to think about a little bit, and the panelists, is the AI technology closing the gap between the atmospheric sciences community and the end users? It feels like it could become the kind of connective tissue linking the weather effects to the grid outcomes. They're such complex relationships, and AI can tease out those relationships. And I wonder whether we're going to see ultimately a move towards directly forecasting power in end-to-end models, where we put data in at the beginning and we get outcomes that are real grid outcomes out that don't need the same level of interpretation. But that feels like we have to get it right with respect to what the objective is. And so so mentioning things that I feel we missed is one of the areas that I think we need to focus on is probably metrics in the future. This morning, we had an amazing session on the use of weather data sets for planning purposes. And I think it was made very clear by the panelists just how important having really high quality weather data for the energy transition is. I feel in many respects like we spend a lot of time talking about forecasting in this meeting, and I was really glad to see that we had a really strong session on the use of weather data downstream, because you can't forecast your way out of variability. You have to plan your way out of it. There was so much going on in the parallel sessions. I think in this session now, I'm going to ask a question before we do it of is this session bringing it all together to allow us to stay out of the silos, and we'll see how that goes. And I'll leave it at that.
Awesome. Thanks, Justin. So, we're title of the session here is Future Needs for Forecasting in Power System Applications. So I think what we'll have our panelists are going to share, reflect on some of what they heard over the last 2 days as well, and some key themes that are important to you. I think we will hear actually a bit about metrics through this panel, but also what you and your organization are thinking about next. What's sort of the next thing, things like this, merging of AI and weather models together, and some of all these different themes that we had. How is that impacting you at your organization as a forecast provider or developer, as well as a user of these forecasts, and how that might be used differently in the future? So I think we'll start, Matt. I was going to start with you, and then we'll come this way, and have some opening remarks in that, and then we'll have a few questions, and then we'll also open up to the audience. So Justin, if you don't mind handing the microphone to Matt there.
Testing. All right. Sounds good. Thanks, everybody. Matt Cote from UL Solutions, Director of Forecasting there. As was already mentioned, I wanted to start out just by saying a few words about John Zach. We've heard different people at different times during the conference share some memories of him and the impacts that he's had on the industry, and also the relationships that he's built. I wanted to share my perspective as somebody who worked with him for many years. Quite honestly, I would not be where I am without him. He hired me directly out of grad school, and really was a great mentor to me, to many people on our team that I have worked with in the past, continue to work with now. Both in kind of bridging the gap. I mean, I have a meteorology background, but then kind of helping to educate me on the energy sector and renewable energy in particular. And I like to think that I bring a lot of what he stood for and what he brought to the industry and what he brought as a person, just to the things that I do in my work, and having the opportunity to share, some of what we're doing here, with all of you as well. So thanks for all the stories. I've had a chance to talk with some of you during the conference about John, and share a lot of good things about him as well. So, I say I wouldn't be where I am, without him. I really wouldn't even be sitting in this seat if it weren't for John. He was the one who brought up my name to the ESIG folks to have me come and present and talk to you all today. So very grateful for that opportunity, and I hope we can, kind of celebrate John and just recognize, everything that he's brought here to all of us. So thank you. So now on to the topics at hand, kind of reflecting on the sessions. It's been a great conference, bringing a lot of people together. I think that may not get as much opportunity to interact as we would like, and I think it's great. And I've heard from a lot of people about how that interconnectedness really kind of fosters a lot of good discussions and motivates people to try to do better and look at what's next. So we're a provider of wind and solar forecasts to some of you here, and to many others as well, around the country, around the world, really. Some of the things that we're looking at right now as challenges, and we've heard some about it here in the conference the last couple of days. Extreme weather events, specifically as they apply to wind and solar, and probabilistic forecasts. I think it's great that a lot of people are trying to use probabilistic forecasts now, and kind of quantifying the uncertainty and the risk associated with all of those things. When I think about what's an extreme event for wind and solar specifically, sure, you can think about some things that are traditionally thought of as extreme weather events, severe weather, hurricanes, blizzards, things like that. And those certainly have impacts, but it goes way beyond that when it comes to just the operations of wind and solar plants. Yes, wind cutouts, turbine icing, snow on solar panels, temperature cutouts as well. But other things like panels soiling, snow on the panels, just the overall variability associated with these things, wind and hail stow, wildfire smoke. There's all of these kinds of hazards that have different impacts to wind and solar generation than what you may see like from the general public. What constitutes an extreme event for the general public or for the power grid as a whole may be a little bit different than what affects wind and solar in those ways. So when we talk about representing those things in probabilistic forecasts, it gets a little bit tricky, because I think what a lot of us think about when we're talking about probabilistic forecasts is, a confidence band or a percent chance that something's going to happen or something like that, and then trying to decide what you do with that information. But then when you get into these other things that are not exactly related to, they're related, but they're not directly related to the weather that's happening right now. Like, how long is snow going to stay on solar panels? How long are panels going to stay soiled? Are they going to get cleaned? Are they going to get washed away by rain? And things like that. You can see bumps up, in addition to the normal variability. And even when you talk about normal variability, what's important for wind and solar sometimes may have very little impact or visibility to the general public. It could be a stationary cold front or a stationary front that's near, a large concentration of wind farms, for example, and you have this oscillation kind of around that can really adjust the wind patterns by a meter per second or two, which can have a big impact, and things like that. So the thing that I want to get at is, how do we represent all of these different risk factors in probabilistic forecasts? Is it in probabilistic forecasts directly? Is it in alerts? Is it in some other format? And so hopefully we can get into some of that conversation about what the end users want to see as we go from here. So thank you.
Hi, I'm Leah Campbell. I'm a senior scientist at Vaisala Weather. We're also a vendor of solar and wind power production forecasts. I come at this from a weather background. learned a lot more about the other side of the equation here, so it's been great to be part of this. But I thought as Justin mentioned, one of the big themes that I heard in this workshop was the use of AI. And, there's obviously some really exciting big advances that have been happening. And I hear over and over the question of how should we be using this? So I thought I'd just try to synthesize some of the themes that I've heard, and maybe offer some perspective, just personal opinion maybe, of how we should be leveraging these technologies, which obviously so many of us here already are very well. So when we think about AI, one of the early presentations in this workshop presented the idea of the AI umbrella that I think in modern culture, we think of AI, we think of ChatGPT, we think maybe of these big, well, in the weather prediction community, we think of these weather prediction models that are forecasting weather around the globe. But AI is so much bigger than that, and it falls along a spectrum. And in reality, it's rooted in fundamental statistical relationships that have just become more easy to tap as computational resources have grown and become more accessible, and we can access more big data. So I thought of the themes that we've covered in kind of three categories. The first is probably the elephant in the room. It's these global weather prediction models. We had some really great talks on those early in the forecasting part of this session. And these are really exciting, right? They're a new frontier really in weather prediction. But what I keep coming down to is that they're not a silver bullet yet. They're advancing really fast. But when you look at these analyses of how well they're doing, they're about comparable at this point to our traditional weather prediction models, which form the foundation of our wind and solar prediction forecasting. So in my mind, it's exciting, and it could change a lot in the next few years. But right now, it's just one more tool in our toolbox. And in my mind, I'm going to be integrating the AIFS, for example, into our ensemble of weather models and just using it as one more piece of information. And it probably does some things better and some things worse. And if our system is structured correctly, it should account for that. The second category that maybe we didn't even touch on quite as much in this session are just components of a forecast that need more creative answers. For me personally, that question right now is nowcasting. How can we get the sub-hourly spatial resolution in the 1 to 2 hour lead time? We didn't see a lot of presentations on that during this session, but I think we can use AI technologies to develop some more creative answers to that question. And that's something I'd really like to work on in future years. And then the third, which I think we saw most prevalently, is the use of AI as a post-processing method. So as I said earlier, we're all using this ensemble of different weather models to give us the range of possibilities of what could happen. And we need to combine those in some ways and go from, say, an irradiance forecast to a power forecast at this one specific site, which maybe has a lot of outages, There's all these different levels that come into that, and AI can be a really powerful tool, which we've seen over and over throughout the last couple of days of post-processing those outputs, making some nonlinear connections, doing those bias corrections, factoring in the different weather regimes. And that could be applied either all at once or in different steps. There's lots of different ways you could approach that problem. I tend to lean towards a more physically based approach. So I like to build good science at the foundation and maybe use that as feature engineering to go into my AI model at the end. There are other camps that like to do it all at once, and I think there's pros and cons for each approach. I find the physically based method to be pretty flexible for some of our client needs. We can start up a pretty good forecast pretty much immediately at a new site, even if we don't have observations. Whereas a lot of forecasting systems that rely heavily on AI for the whole workflow say, oh, we can't spin that up until we have 3 or 4 months of observations. It's like, well, that seems like a drawback to me. So lastly, that just reminds me of some of the limitations of AI that I think we all need to keep in mind. First is just that we need good observations. And if you don't have observations, you can't build a skillful model. And that feeds into the fact that AI models they're good at what they're trained to do. We've heard that over and over. And they're not so good at things that they haven't seen before, or potential extreme events that could happen in the future. So those are all things to keep in mind in how we want to balance the physical science versus the AI methods.
Excuse me. Just want to quickly second the need for nowcasting of solar. It's definitely a strong need in the industry. But as a load forecaster, I'm John Black, load forecasting at CAISO New England. We have the distinct pleasure of working in both short-term operational time frames and in long-term multi-decadal sort of forecasting situations. So that's what I'm going to try to shine a light through here on this panel as best I can. Starting off with the short term, I think a great growing need in industry. I mean, if I think back, I've been involved in ESIG for, I don't know, coming on 15 years now, I think, on and off. And at the beginning of my participation in ESIG, I remember hearing a lot about probabilistic forecasting, particularly with wind. Fast forward to today, and I'm really heartened to see a lot of my colleagues now using probabilistic forecasting and really working hard to figure out different use cases and how to apply techniques that we've been hearing about for a long time. So in that space, I feel like an emerging need is to really root our sort of quantification of uncertainty and preparation in the operational timeframes more in the state of the current atmosphere and what our latest and greatest best tools say about the future states of our atmosphere. That's not to knock anybody. You know, there's been a lot of good work quantifying uncertainty based on historical forecast errors and things of that nature. I just think, especially when you start thinking about some of the potential with AI-based weather prediction, I think there's a lot of room for really thinking about large ensembles of forward-looking forecasts and being able to think about what our atmosphere is telling us the sources and the magnitudes of those uncertainties are going forward. Shifting gears to the long term, which I feel like the focus of this conference is largely on operational timeframes. So when you think about long-term forecasting, I think long-term load forecasting has kind of risen to one of the primary determinants of long-term planning, right? There's so much load growth happening for a variety of reasons all across the country, and there's so much uncertainty. And so if I think about long-term load forecasters, you know, we have a long history of doing good things like figuring out what weather might there be at a certain time of year and what's the relative volatility in what load could look like and how to find sort of, you know, probability of exceedances basically in load likelihood based on that weather. But a lot of the uncertainty we're dealing with now is technological or policy oriented, things that are emerging that we don't even really see clearly yet, and we have to find a way to model them out multiple decades into the future. So I really think finding a path to reasonably develop scenarios that help bound that uncertainty for long-term decision-making is critical. It's probably in the long-term space, I see it, at least from my vantage point, as one of the critical needs in that space. So thank you.
Great. Hi, everyone. David Larson from EPRI. I lead our load forecasting initiative involved in DC Flex, kind of anything forecasting at EPRI. And I think most folks are familiar with us that we're a nonprofit research institute. So we kind of sit between that part of we are working with the forecast providers, sort of as end users to understand what they're doing and provide input. But we're also working with folks like utilities and ISOs using these forecasts, whether it's on the shorter time scale, as John had highlighted, or the longer term. Couple of things that have come up during this session that I did want to sort of reinforce as areas that I think are important, or as we're thinking about it. One that John had covered about, for a variety of reasons, thinking about looking just in the past history may not be sufficient, and thinking about what we need in the future. And that could be both because of weather, but it could also be things like, well, we've had this weather before, but we haven't had the power system we've had then. And so thinking about what can we do and what do we need from the forecast to handle that, whether that is on the shorter term or longer term. Which goes to my second point that has come up a bit during the session about we want to improve forecasts, but we need to be thinking about how those forecasts are used, because ultimately we want to improve the outcomes. And we should be using that information, and things like ESIG are great to bring us together to understand from the different perspectives of what do people need and what's actually most important to improve. And some of that may be purely technological of we need improved models for a specific application. Some might be thinking about how we use the forecasts. And I know for probabilistic, sort of a common theme that always comes up is we're making a lot of progress on improving the probabilistic forecasts, but everyone still feels a little bit of struggle on how best to use that information. And that's kind of maybe a bigger piece to say, we feel pretty good on the probabilistic forecast piece of making those, but how do we use them, and thinking about what does that mean for how we should give that input? Which comes to kind of the last point that I want to make, which is, I think, again, things like ESIG and others, where we're bringing these people together to sort of provide the info that each party needs. So I like that comment that came up yesterday about, what are some of the things that we need to do, particularly with AI weather prediction models, of coming up with benchmarks. So people that are working on this understand what are those perspectives from the utility or the energy side that are most important. And if you can do that and kind of reduce the friction for more people to work on these problems, I think that opens up a lot of very interesting potential, where it's not this, hey, you're an outsider, you can't work on this, but say, let's bring everyone to the table that wants to work on this. Let's just think as a community, what is most important? Because I think that's a big part is, us working together, come up with what should be those guideposts for us to go towards. And some of that, benchmarks are one thing. I think that's a great topic. That also ties in the need for data, both for things like data sets that we all rely upon and improving those, but also making those things more available. And then just the last point to echo about the collaboration. So it's always great being at this event. I think all of us had experienced this, especially if it's your first time. It's nice to be at a conference where everyone kind of knows the same thing. You go to an IEEE conference or Distribute Tech, there's 20,000 people around. You bump into one or two forecasters. Here, you can be like, I don't know you. I've tried to explain this to my family a million times. You instantly get it. And I really enjoy that. That's very nice. This is a great event. But yeah, I think continuing this sort of thing, us working together, there's lots of great potential there.
I did not want to follow David Larson.
Who's that you?
I just want to say thanks for having us. We're looking forward to this session all week. Want to echo the comments Debbie made at the beginning of the opening session on concerns for the industry. I think we're focused on that as well. But I want to say this week's encouraging. Probably more importantly, meeting everybody, seeing the things you're doing is exciting, and we're fitting right in with that. I've met a lot of you, but if I have not talked to you directly, I thought I'd introduce myself. So I'm Brent Duncan. I work for Southern Company. Southern Company's group that I'm in is fleet operations, and that includes the unit commitment team and the fleet desk operators. So what I do for them is solar forecasting and integrate solar into their tools and into operations day to day. So a little bit of history on where we are. We were 2 gigawatts of solar a couple of years ago. We're at like close to 5 now. And in less than 2 years, we'll have 8 gigawatts. So it's a fairly quick increase in solar and in complexity that it adds to the fleet. And so to sort of de-stress this, we've done a few things in the last 12 months that has improved some things. So we have Vaisala, and Jeff mentioned a perfect forecast. We get a perfect forecast from Vaisala. But to further strengthen the view from forecasting side, we added a secondary vendor. And so for both teams, we have inter-hour forecasting. That's new to us. And then we added probabilistic forecast. So sort of first task as I begin to look at these new features and talk to operations is they're like, you're overwhelming us. So we focused on inter-hour forecast, the deterministic view, and integrated that into our tools over the last 12 months. So that's a first major step for situational awareness to that team. And our second task, and I've been working with David Larson on this more specifically, is aggregating probabilistic forecast and then creating better visuals and information for them to be able to make decisions. So that goes back to the part that he talked about. He's seen us struggle with that piece. And ultimately, as you aggregate probabilistic forecast, it's not a trivial thing. So you have to compensate in real time for any kind of maintenance outages or curtailment, and that adds complexity. And then you have to make broad decisions on that. So that's kind of where we are with the probabilistic forecasting side. Our goal with that is to finish that maybe later this summer and then begin to implement that first in the unit commitment team towards the end of the year, and then use it in the fleet desk operators beginning of next year. Erik mentioned a few minutes ago something about metrics and forecasting, and I thought I'd add a little color to what Will Hobbs presented yesterday. We did an EPRI arbiter trial, which I advise everybody to do that. I thought it was a great thing. David talked about it in general, gave a lot of general feel for what happened. But it was really interesting, and this is the challenge that I think one of the utilities that's consuming your forecast is focused on. I thought Leah did a good job she and I've talked a good bit about these aspects, so I think she did a good job at seeing where we are and where we want to go. But one component of the trial that we all saw is like as each team began to forecast at the beginning phase, they had a kind of a disparate view of how the forecast would work. And then as they begin to see how they would compare to each vendor, then they're like, oh, okay, we need to adjust this and we need to focus more on the average because our statistics begin to look bad compared to somebody else. Well, the disadvantage on that is that, hey, maybe you saw something that was going to really spike in the beginning of the day, which would have been valuable to the operator. And Clean Power Research actually brought that out yesterday, and Will Hobbs brought that out. So that was the background and sort of the genesis towards novel forecasting. So we need both. I mean, I feel like it's a strong metric to use, normal mean absolute error. I think we live off of that day to day. If you're an operator, you want to know about on what am I going to get, but you also want to know that other component, which is what's the risk here and how big is that risk? And so when you talk about tails, statistically, I think Rob did that earlier. That's a good component to begin to think through as an industry and work together to more of a final conclusion on that. So I want to say thank you for having us, and I look forward to any questions.
All right. Hi, everyone. I'm, excuse me, Rebecca Webb, Manager of Operational Forecasting at CAISO. And this has been my first ESIG, so it's really exciting to see, all the development, the passion, the, need to figure out what does the end user really want out of our products. So I've been very excited to, have all these discussions and see what's coming as technology is changing so much. So I'll share a few stats from, CAISO. I talked about it a little bit yesterday. Our, peak load is 52,000. Currently we have 21,000 of grid connected solar, 8,000 of wind, and 18,000 of behind the meter solar. So with all those renewables, we also have 13,000 megawatts of battery. So that's about 14% of our capacity, and it's our fastest growing resource. So really understanding the best way to use those batteries is really important, since they provide capacity during our net load peak as well as ancillary services. It's a great tool, but figuring out where they can assist with the large amount of renewables puts a lot of focus on forecast accuracy and making sure you understand where you're going to have that renewable energy and best place to utilize those batteries. So that's where forecast accuracy becomes really important for us, and helping the market optimize these resources and ensuring that they're charged and available to use when they're needed the most. So overall, yeah, I think I'm just excited to hear about forecasting advancements. Excited to work with you all to help us understand the risk of where the forecast can miss, where it's going to nail it, and just kind of continuing to provide a reliable service and a reliable grid.
Great. Thanks, Rebecca. Thanks, all. So we're going to talk about a few different themes and encourage folks to start thinking about any questions you might have, and we'll open it up in a bit. But I wanted to start, just a question for Rebecca, Brent, and John, and really just kind of this theme of the workshop, and I think shared a few things during your opening remarks also, but just sharing with us all whether it's through workshops like these or working with your forecast providers at your respective organizations, what is it that you've learned about how these forecasts are developed that has really helped you, figure out new ways of using it, or figuring out how best to apply these, whether it's probabilistic forecasts or the different types of horizon, time horizon forecasts, things like that. But what is it that you've kind of learned? In other words, if you had if it was a black box and you just got this data versus what you have started to hear from all the folks through these meetings and other things, what has really helped you in how to apply those forecasts?
All right, I'll kick it off. I think really understanding which models are going to, accurately forecast certain situations versus which models will have trouble is something that's really important. Again, going to that theme of understanding the risk and what scenarios have higher risk. So for example, like the HER model, being able to incorporate smoke impact is really helpful in California. And that's something that we'd rely on, during wildfire season, to help us capture, better irradiance, better temperature, that kind of thing. So getting knowledge on quantifying that risk of the black box and what scenarios you really have to, have more insurance is helpful for us.
So we spent a lot of time in the arbiter trial looking at different components for weather feeds for our PV lib model. And so if you take different weather predictive models and look at what type of results you get and compare it to other standard forecasts, you gain a lot of insight for accuracy, what you can trust and what you can believe. And I think that from our view, the deterministic, it seems pretty established. I think what I have been trying to learn more about is the probabilistic view. I think the workshop that I went to last year was really good here in ESIG. I think this week's workshop was also really good as well. So I think I still have some gaps on how we can consume that, how those risks are evaluated, and then more importantly, how we can make better decisions off of that.
Yeah, that's a good question, Eric. I guess I'll bring up, so we've been hearing about other organizations' woes with high penetrations of behind the meter PV for years regarding real-time load forecasting. And we finally had completed a project at ISO New England about a year ago, or a little less than a year ago. And now we're experiencing it ourselves. We have about 8,000 megawatts of behind the meter solar on a roughly 25, 26 gigawatt summer peaking system. So pretty high penetration, probably just a tick behind CAISO's behind the meter penetration. We don't have a lot of front of the meter renewables, so behind the meter PV is really our biggest issue that I think that we're dealing with in terms of weather-driven resources. So part of that system that we designed and built, we have 3 behind the meter PV forecast vendors giving us 5-minute interval forecasts every 5 minutes. And the learning experience has been that, hey, forecasting on very short time scales, to your point in the opening, for behind the meter PV is very difficult. And so the way we've designed our system is such that, you know, when the behind the meter PV forecast is off, we see it directly in our load forecast. So that's kind of the issue we're dealing with right now. Kind of a shame on us. We maybe should have seen this coming, but we're just learning on the go here. Tying back to the question, what we've noticed is that the patterns of each vendor's errors and respective biases are a function of look ahead period and time of day. Those are the 2 kind of critical dimensions. And to the question, really the characteristics of each vendor forecast along those 2 dimensions has a lot to do with each vendor's methodology. And that includes the inputs into those methodologies at different time scales, different look ahead periods. So, you know, out over the first couple hours, you know, there's sort of different patterns of errors. And then once you get beyond that, you start seeing the respective vendor performance change. And I think that's because there's a transition to using more NWP-based inputs into the forecast along that time horizon. The other thing is working with vendors. And so I will say that we did a lot of our own homework. And so we didn't necessarily learn this at ESIG, but we could have, and we learned more by talking directly to vendors at ESIG. We have a nowcast, so we have ground truth data that we're getting very low latency, close to real time. And, you know, there's a difference in sort of the amount of experience that vendors have in leveraging that real-time data into improving forecast on very short timescales, very short look aheads. So really, it's the work in the discussions with the vendors that we can learn how to leverage as best we can, you know, the best signal from those 3 vendor forecasts every 5 minutes, in combining them into a final behind the meter PV forecast that's an input into our real-time load forecasting process to try to mitigate as much uncertainty as we can.
Thanks, John. I'm going to basically pose the same question, only the other way around to the vendors. And, you know, it's interesting to hear both John and Rebecca and Brent as well, actually, all talking about sort of the attributes of the forecast. One of the things I've wondered for a long time is I feel there would be a lot of value in having like a benchmark forecasting system where, you know, vendors participate in forecasting for various different sites in different climate zones around the US, and it provides them with the opportunity to see how they're doing against other entities if they did it anonymously, and provides people with an opportunity to have a understanding of how different vendors do in different spaces. But anyway, coming back to my question, as a forecast developer, what is it about power systems that you don't understand today that would help you improve your forecasts, what support could the sector provide in enabling you to better service their needs? So for example, do you need better renewable energy data, better load data, more timely data, better insight into the way that the forecasts are being applied, and more input into the forecast form, like deterministic versus probabilistic. So there's a lot there. Pick the things that you want to cover and which you feel are the most important, and anything that I've missed.
Well, I think I want it all, but obviously more data is so helpful. I think one of our big challenges is that we're not just forecasting weather. We're forecasting things that happen at an individual unit level. And the more data we can have, the higher quality data, the higher frequency, the better we can handle those things. Talking about outages, curtailment. We do get information about future outages from some of our clients. That's hugely helpful. So that's one thing. Another theme that I have really focused on during this workshop is, I guess, a clearer communication between users and vendors of which validation metrics matter the most to them. We always say among ourselves, I wish they could just standardize it and just tell us, you know, we do want the MAE to be the best, because that's what our system could be built around. But in reality, every system is so different. The requirements are so different, and being here has helped me see that we're never going to get that level of standardization. So toss that out the window. And I guess the next best thing is just really clear communication on an individual client vendor basis of which metrics are most important to us, which lead times, when do we care about ramps? Do we care if you get the timing of the ramp exactly right or not? All of those things really help us build something that can meet your needs. And as we gain more understanding of how those requirements change between users, we can develop flexible systems that then can be tailored to individual users' needs.
Thanks, Leah. Yeah, I mean, all of that. Again, I mean, there's so much there, and I'll hit on a few things. You talked a little bit about outages and curtailments. I'll talk a little bit more about those. I can probably point to several people in this room who will say that some of their largest forecast errors are because of incorrect or just missing outage reporting data. And that's, yes, people can submit outages. They don't know when they're going to end, when they're going to start, how much the magnitude is going to be. But beyond that, what's the ground truth of what an outage actually was? So in real time, or even historically helps, what were the actual start times and end times of those outages? Because those really modulate, you know, what the perception of forecast accuracy is, what the actual forecast accuracy is. So sometimes we're asked to provide forecasts just of, you know, the wind is going to do what the wind is going to do. You know, the clouds and the sun are going to do what they're going to do. What's, aside from all of that stuff, outages and curtailments, what is the forecast just based off of the fuel type? So we can do things like that through, you know, estimating what the plant can produce when there's an outage, when there's a curtailment. Sometimes we're able to get some kind of an estimate from the plant itself. It may be called like a high sustainability limit or something like that. And we can train our models to that. And then outages and all those other things can be handled, you know, on the back end aside from us, you know, and things like that. In terms of other data that we can get, I will echo what you said. The more data, you know, the better. There does seem to be a bit of a disconnect between those that like the plant owners and operators, where the measurement devices are actually located, in terms of what data is needed, how important it is, you know, how it's used, what are the benefits of it, what happens if you don't have that data. And the communication pathway, I think sometimes between system operators and the plant owners and operators and the forecast vendors, sometimes that communication channel can break down a little bit. It can take a long time to get information. So how can we address these kinds of issues? Equipment malfunctions that needs to be repaired. Sometimes data is out for a long period of time, and we do everything that we can, to estimate, what's happening at those plants given the available data that we have, to try to continue producing as accurate a forecast as we can in real time. And then speaking about like the metrics and the validations, it does all come down to communication. We've run into some instances where, somebody will say, yes, I want, an RMSE or an MAE reduction, based forecast. And that can be kind of a standard approach. It's a standard type of metrics that people use. But then when you have the users of the forecasts who are actually, making decisions on them and feeding them into downstream processes, they'll come to us subjectively and say, hey, this type of an error caused us a problem. Maybe they'll notice a pattern. Maybe it'll be a one-off event. Every bit of intelligence that we can get to try to get at what really causes a problem for the end users can help us to tune the forecasts in a better way. Coming up with the metrics is an important parallel to that. Sometimes it's a little bit hard to capture some of these complex situations. We do have users who try to do it, defining complex metrics that maybe only a few people understand and others don't, and that can impact adaptability of those metrics and things like that. So in short, yes, it all matters. We're concerned about all of it. We talk about a lot of it with a lot of our customers.
So I'm going to ask a follow-on to that, and you guys have sort of answered some of this, but I want to throw it open to the entire panel. So we have. You want to say something? Go ahead.
So that's a pet peeve of mine. I'm going to make a comment about that. So when I first got into this role, there was a lot of outages unreported, and we do not tolerate that in any other situation. If you had a nuclear facility go down, they're like, oh yeah, well, we didn't tell you about that. We're sorry. Oh, we came back online. Oh yeah, we're good. And that's got to stop. And I'm super impressed with CAISO. I talked to a lot of utilities that manage lots of solar, and I think in general, we've just got to work collectively to make sure that if you're doing a good job forecasting, that's the only dilemma that you've got. You don't have a dilemma between forecasting and outages. And then the planned outages and unplanned outages should feel the same. Transmission curtailments should feel the same. CAISO does an amazing job on it. I talked to them about it last year, and I just feel like that should be the type of standard that we create.
Yeah, so following up from that, and Dan, I've been on both sides of this fence, and I know that availability is probably the biggest source of forecast error, which in this day and age is a real problem. And it's a hurdle. So that kind of leads to the question that I've got here. So we've talked in the workshop about how important data is to the process of forecasting, but also to the planning process as well. So you've talked a lot about what data is out there that could potentially greatly improve the forecast. Can we try and expand a little bit and see how we can get over these hurdles? So, I sort of see the quality of data as being almost as important to a renewable energy future as transmission is. It's sort of analogous almost in its importance level. And we seem to have a hurdle because we have developers who don't want to share their data. And then we have system operators that force them to share their data in order to be able to produce forecasts, but that data remains proprietary. And then they have the rest of us who would really like to push the ball forward. How do we break this gridlock? Any ideas?
So just so I understand clearly, what type of data are you talking about sharing?
Well, so I think all available data from plants, availability data, power generation data, wind speed, all the meteorological data, we're building out this amazing network of meteorological data and also of data that can be mined to understand availability and outages that are weather driven, etc. But it's all hidden right now. It's dark. It's dark to the entire, to everybody except for system operators and a few vendors who have gathered a large database of it. And I see that as a real problem.
Yeah. So I just shameless plug for a NERC team that I was on recently. NERC Val 7 tried to focus the industry on the fact that you do need data. And so what we did is change TOP3 to make sure that the entities that will need or share data would know what's happening in real time. So a lot of times there's been some resistance in sharing that information. And if you think about grid reliability, you've got to have it. You've got to know what's available and how you can make decisions off of it. I think ERCOT's BA came out recently and talked about that, is that they try to go out and say, we need this much AGC resource from solar. We need you to respond this way. And unfortunately, they haven't been able to trust it. And so I think that's a glaring situation that could be cascaded across the industry. So we've got to figure out how to share that data and how to do it the right way. And as we talked with all the BAs and RTOs, et cetera, I think that comment, and we de-stress the industry by making sure TOP3 is clear and that you can ask for the data and that you'll know what's happening on availability in real time.
Yeah, and actually, thanks for that, Brent, because it kind of brings up the point that I meant to mention as well, is who are the right organizations for us to push this through? Is it organizations like ESIG, or would it be more organizations like NERC or FERC? Or, should we be trying to do this as a common group where we're, trying to not do it within a regulatory framework, but just understand that it's a common good?
I could maybe make a comment along these lines. I mean, EPRI's EPRI, not necessarily saying we should do it, but I do think sometimes depending on the use case, there might be different solutions to this. There may be things where it's like, well, is the data we're talking about that we need to have more data from like actual power plants of different areas and have a historical data sets or benchmarks that you could provide to all forecast developers. Now, if that is maybe just the commercial ones and you say the way we're going to do it is we're going to have NDAs, it's not fully public, but it is more accessible than if everyone individually has to go and try to fight these same battles on their own. Maybe that's one approach. I know there's lots of discussion on kind of other topics in that industry, energy industry, about synthetic data sets. And maybe that's sort of one where maybe that helps get over some hurdles where you say, okay, you're not going to give away the private sensitive data, but there's some sort of process wherein synthetic data can be shared that still sort of meets most of the goals. And maybe that's something that kind of goes through. Who should do that? I'm not sure. I feel like it is something that you have to do kind of collectively. I'm not saying we need a 100-member working group, but maybe sort of hey, there's sort of someone in the middle kind of organizing it and trying to bring others to the table. That's kind of my perspective on it, but I don't know if others have thoughts.
Sure. I mean, this is a great discussion. We're talking about it here. A suggestion might be to have a session at a future ESIG forecasting workshop. Can we bring in some of these types of people that ultimately have the data and have a panel or start a discussion with them, right? And it's at least some place to start.
I want to add two more things. It's been shouted out a couple of times at this conference about ERCOT has a lot of very nice data, the 60-day SCED reports. So that is 15-minute data for every power plant. You have the curtailed, uncurtailed. It goes back since, I think, 2011. That's a really amazing data set, and we know some folks are already using that. Maybe that's kind of an example of like, we need more of that. And I don't know all the details of why it's set up that way, but just the name is that it's a 60-day delay on the data, which, yeah, you're not going to use that for real time. But if you're a forecast developer or someone studying it, that's really powerful. The other one I'll mention, and not to make it a plug, but it came up. So we've done forecast trials before at EPRI, and I think generally we've had positive feedback from the participants where we're able to bring in the utility that has the data, set up all the legal stuff, and then have multiple forecast developers involved. And the general feedback we've received from that is, this is great because normally I don't see this type of data in this region. It might be new to them, like they haven't got a contract yet, so they don't know how their forecasts perform. But the other part is they're seeing real data and they're seeing how they're performing to others without revealing who they are or knowing who else. They just get a sense of, where am I? Maybe that's one way that is, it's not a full solution, but maybe it's a starting point of doing more of those to say, what we want is the developers to have more access, and it is in sort of a controlled way, but it is making progress. And then maybe from there, as people get more comfortable and everyone sees the value, say, oh, that was really great. So if I give this data, it's not really a concern anymore, and I'm getting this big value out of it, which ultimately I think for a lot of folks, there needs to be that value on both sides. Otherwise, everyone's busy, everyone has limited budgets. It's very tough.
John wants to wait.
I'm
I want to
gonna
make
give
sure we have time for the other questions, so keep it
I just
relatively
want to
short,
say,
but
not
please do wait.
not meteorological data, but I just want to say that there's a lot of other data that would be useful to have for planning purposes long-term, and then also operational forecasting as well. When you talk about DERs, a lot of talk about, the metadata, where's PV installed, how much of it, what are the design characteristics, and then the operational data, like how do you get a sample at least of real world systems to put your estimation process together. Those are critical for DER PV. A lot of other issues we deal with in electrification forecasts, heat pumps, types of heat pumps, the specific uses and applications of those heat pumps really is needed, and then real, like maybe it's AMI data, some metering data to really understand and improve upon modeling heat pumps. Retail-based active DR programs, reducing the peak is great, but when you start impacting the short and long-term load forecast models in sort of ways that you can't really sort of explicitly see or control for, all of this is really important as well. I don't want to just focus on meteorological data. I know personally, I'm really interested to see what happens in California, where there's a huge sort of open source DER database, something or other happening. And I just want to point that out, as that's really, really important as well.
Yeah, those are great comments. I'm going to hand off the mic to Erik. I just want to say something really quickly. First of all, thank you for putting the plugs in, David. I didn't feel as co-chair I could do that. But secondly, the ERCOT point, I was hoping that once that domino went, that the rest would go fairly quickly, and they haven't. We have to kick another domino over. So please, if you're a system operator, if you can try and put that plug in to get the data made transparent.
I wanted to shift gears slightly, but talking about probabilistic forecasting, it was really helpful for me to sit in on the probabilistic forecast user group, which many of you also participated in earlier this week. And it was, I think, really neat to see how many folks are using that data. But what I also saw is that this, and Dave, you talked about this too, just now, but that we're all sort of still kind of struggling knowing what to use it for. And so I think, we're providing this data to folks that can use it, and then the folks use it, and there's sort of like this intermediary step of kind of processing it. What decisions can be made out of this? And Rebecca, you talked a little bit about how it's starting to be used in reserve requirements and things like that. And I just want to hear, like, is there another group is there another sort of expertise needed on processing this to help operators make sense of that data and kind of know what types of decisions to make from it? Is there more to do on the tools? Is there anything where that kind of data can more explicitly be used within, the same types of tools that the deterministic data is used? Where's probabilistic forecasting going in the future?
Right. I mean, I think that'd be great to be able to, automate that use a little bit. From CAISO, like I talked about, it's really used in the sense to understand how much risk you have, really. It's you know, if you're getting this black box forecast and you run with that, you know, just kind of not understanding if it's likely to hit or miss, then you open yourself up to, you know, some of your erring and some of your extreme situations, right? So I think having these probabilistic forecasts and seeing, you know, days that have a bigger range of possibilities really helps in preparing that insurance to, you know, make sure you're not missing big is kind of how I see it.
Yeah, back to the probabilistic, case, obviously very important. We've given probabilistic forecasts in many different forms, and adoption is tricky, right? It's people want to know what's it going to be, right? What I have seen, and this is just kind of anecdotally, inherently wind and solar forecasts are driven by weather conditions, right? And so when we have seen success in adapting to and using additional information, whether it's probabilistic forecasts in the form of a confidence band, but it may be like individual ensemble member forecasts, or it may be showing risks of certain types of weather phenomenon that may cause some really serious impacts, even if it's a relatively low risk. When there's an actual meteorologist on the other end in the user group that is able to understand and take action on that type of information, I have found again anecdotally that the adoption of doing something useful for that information is better and is more advanced than if there's not a meteorologist, or at least somebody who's knowledgeable about that information and what to do with it. You can do automated processes. You can say, yes, okay, I can understand that there's different amounts of uncertainty here, and that may affect, reserve requirements or whatever else I'm trying to do with it. But to try to take it to the next level, maybe a little bit a more meteorological background on some of the end users would be helpful.
Yeah, just to add to that, we think a lot about how best can we convey this information. Our forecasts are automated. We're sending them out every 5 minutes. What we're sending is really dictated by the end user's system and what they can process or what they already have set up and how long it'll take them to change that. I would really like to see the capability to send a fuller picture of the uncertainty. So more than just the P80, maybe a few more bands in there so that you can actually see the distribution and know where the tails are. And then to Matt's point about the operational meteorologists, I think there's a lot of nuance that still goes into it, right? Like we can quantify this uncertainty and convey that automatically, but when it comes down to it, in some of these extreme events, you need a human to go in and interpret the risks. And I'm getting the understanding that users incorporate that step in at different points in the process. We also have operational meteorologists on our staff that could be utilized. So it's kind of a conversation between the forecast providers and users and how can we best create that, add in that level of interpretation. But I was also encouraged to see the presentation by ERCOT about how you guys are pulling in probabilistic forecasts from solar, wind, and load and integrating that together. I think that's a really cool approach.
Just want to point out, so when you talk about probabilistic forecasting, really companies like mine, you become now a mix of forecast users and forecast developers, right? So we develop load forecasts. A lot of companies have vendors, might have different vendors for wind and solar forecasting. You might have different vendors for behind the meter this, front of the meter that. So when you start trying to think about the kind of the problem and the need that I shared at the intro about how do you tie your sort of conception of probabilistic forecasting to the current state of the atmosphere, and the future states of the atmosphere, it immediately becomes very complex because each vendor, in a lot of ways, no matter how much we talk with them, they're kind of just separate black boxes. We have total insight into our tools. We know the data that goes in and comes out of those. And really, like, the challenge is, how do you come up with an overall architecture and design where you can establish kind of coherence across all these different systems that, you know, pass through multiple vendors as well as your own processes. I know, you know, we're kind of last to the gate at ISO New England in developing probabilistic forecasts. And so this is just communicating that that has been one of the major hurdles that we've been trying to overcome in conceiving of, like, everything's changing so fast. What are we trying to shoot at? It's going to take a year or two to get there. What you're targeting is really critical.
Yeah, I'm going to ask one more quick one. I'm going to ask for the panelists to give a real short answer so that we can make sure we've got plenty of time for audience questions, and then a little bit of discussion about the nature of this conference afterwards. So talking about extreme weather, and obviously the definition of what is extreme is evolving over time. So what do you feel are the extreme weather challenges within the energy sector? And how do you think forecasts can be developed or better applied during extreme events? And if we can just get a couple of sentences or so each.
All right, I guess from California, heat waves and wildfires, I think are the ones we deal with the most. You know, we don't have all the systems that happen on the east. So really, you know, being able to capture the temperature forecast during those heat waves, especially when they're multi-day events, is really important to us to ensure that we're, you know, forecasting the demand accurately and, you know, back to my battery point, using those when it's the best time to use those.
Well, this year it snowed at the beach, so I watched it on a webcam. It was wild. So Southern Company is a winter peaking and a summer peaking. That's new. I mean, we used to just be summer peaking only. So I think extreme weather definitely affects us. We plan things differently. We look at resources differently. We also look at outages differently. So I think extreme weather is definitely a huge task that we're all struggling with.
So my perspective is, I think I'm more concerned about heat waves and wildfires, not just because I'm in California. So thank you, CAISO, for keeping the lights on. But I think those, because there hasn't been as much focus on that, I think there's some interesting challenges. Like, I was kind of shocked a couple of years ago when I started hearing about wind turbines getting shut down from being too hot. I'd only heard about that from cold, and then you start hearing this first in like the Middle East, and then you start hearing in other regions. So that's kind of what I'm more concerned about. But just one last one is, I think also it's not just extreme weather, it's just extreme conditions. And that's maybe a growing concern where you have outages. The weather is actually not that bad, but just the conditions are very stressful and you're trying to think of how to deal with that. And that's maybe one that we don't put enough attention on.
I guess transitioning to a more weather-driven system on the supply side, obvious one is, you know, wind and solar droughts together, coupled with, you know, maybe extreme summer or winter conditions, right? Where you just may not have enough energy to support the system.
When I think of the challenges that we face when trying to create an accurate wind or solar forecast, I go to smoke from wildfires. It's difficult to accurately integrate that into our models. And then I always go back to the outages. I think we are evaluated on how well we're predicting not the weather, but the power generation. And we can't predict how that ice storm is going to cause outages yet. I want to come up with some more creative ways of how we can quantify that instead of saying there's going to be a lot of freezing rain. Watch out, I want to be able to quantify that.
There's two things I'll come up with here. One is when there's an completely unexpected period of high error with wind or solar forecasts that's not associated with some kind of big weather event or even localized severe weather, but some maybe local wind phenomenon that's not adequately captured by the available models or the available data. That can cause a problem. The other thing is when conditions are tight on the grid, there are going to be periods where a highly accurate forecast is more important maybe than at other times. It's like you have more tolerance for higher error. So would you want a different forecast, maybe a more conservative forecast of the wind and solar generation during times when you're expected to be tight? And if so, how can we accommodate that? Can we override the forecast? Can you make adjustments on your end? Is there something else that we can do, something like that to help mitigate the risk?
Great, thanks. So do we have questions from the audience? Joe?
All right. Thomas Haley, Clean Power Research. I'm going to ask this question probably on behalf of Leah and Matt. When I think about probabilistic forecasts, we can create them with three main outputs. We can do quantiles. We can do the probability mass function, which could be useful if you have your, it costs this much to be wrong this way and that much to be wrong that way. Run the numbers and minimize your costs. But it sounds like, John, to what you were saying in terms of integrating the forecast, the most useful might be just a bunch of samples from the random variable, because then you can run them through like a Monte Carlo process. You know what I mean? Like if we said, hey, this is 1,000 samples of how much sun you're going to get at your big solar plant, then you can run them all through your simulation and then let that do numerically figure out the complexities in the system, because we can't do that on our end, but you could. So is that something that you want, or if I go back to my product team and get them to do it, am I just wasting my time?
I'll just start off by noting that I'm immediately ahead of where we're at, right? Because we haven't actually done anything yet. But yeah, I think you have it right, but at the same time, there is concern about, if we had 1,000 ensemble members, we want some sense of being able to know what the associated likelihoods are for those members. So we kind of want both. We want the ability to sort of really richly flesh out sort of what the uncertainty is, but also the relative likelihood. And I guess I'll leave it there. I don't know, kind of a non-answer, sorry.
Yeah, I think we're maybe starting to see some of this. I've been trying to argue for the case for more scenario-based types of forecasts, because the confidence band approach, quantiles, what have you, is just, I think is pretty ingrained in what people are thinking about, and it's got its place. But when you want to know what's really kind of the potential time window when a ramp might happen, or what are the potential magnitude ranges of how strong it might be, things like that. I think it kind of requires a bit of a different type of forecast, more of a scenario based. So could you get to a place where maybe you provide, maybe it's not 1,000, but maybe I don't know, 10 or 20 or something manageable, at least to start, that kind of at least covers some of the range of outcomes that you might see, at least from, coming out of your ensemble, which may be under dispersive, but at least it's something to give you some ranges there. Could something like that be helpful? And if so, then, I mean, we can certainly provide it. But again, conversation with the end users.
I think it would be helpful. I think it fits into the novel forecasting that we talked about. I think if you look in general, I have maxed out the structuring analysis team that I work with. They're doing all kinds of things to support new probabilistic views. I don't think we would be ready for that, but I think there probably are customers that could use that.
All right. Hi, everyone. I'm Joe Mulhern from PJM. This was an excellent panel, so thank you. I'm very interested in the role of the human in forecasting, so processing the data, making decisions, both the meteorologists and the control room operators. And this came up in 2 or 3 questions ago. There seems to be a lot of focus now on the humans, the operators as the end customer, presenting as we try to figure out how to best leverage probabilistic forecasts, presenting information in ways that are useful, where they could ultimately make good decisions. And right now there might not be a formula for those decisions. But do you see that? How do you see that evolving in an age where knowledge work is increasingly at risk of getting replaced by AI? Do you see operators going away? Do you see their role shifting or being more in deciphering the meteorological details? How should we think about the potential shifting role for operators and just control room staff in general?
So I don't know if I have to do a disclaimer that this is my personal opinion, not of EPRI, and it's open power AI stuff. Anyways, I feel like there's a lot of potential for this to augment the role. I personally think you see a lot of parallels in some of the industries where there's still value in having human experts in there. There are obviously challenges. I know I've talked with many folks about you not having the same sort of workforces you're used to, where you have someone that's been there for years and years. You have someone coming in new and they maybe can't draw upon that experience. So you're wanting tools to help them out a bit more. I think maybe there is a world in the future where things get so complex and at such a high scale that you need to automate further, and that's sort of what drives it. But I think at least in the shorter term, there's still going to be this role. And I think when we talk about probabilistic as an example, I think the reason we're talking about all these pieces is partly because there's this thought, I know it came up at the probabilistic users group about why aren't we talking about like stochastic optimization? Isn't that just supposed to solve it? Like, why don't we switch to that? And there are different reasons for it, but I think where we're going is still have the human in there, and a lot of this stuff is sort of decision support, and there's going to be those things that humans are expected to still be the best experts. They're not going to come up with the weather forecast themselves, but using that together, and that's kind of how I see it. Is it is going to be this thing in the future. It might change on the role where you say, yeah, I don't really want you sitting there looking at 100 ensemble members, but I'm going to give you this and give you some guidance that when this happens, do X. So that's kind of my view. I don't know if others agree, disagree.
So with the big caveat that I'm not the user, but I would like to see a mix of both, kind of like what David is saying, using AI to the best of our ability to create more informed tools that then the human can leverage more easily to synthesize large amounts of data, get a better understanding of the range of possibilities. And but then in the end, the human is the one at the end of the chain that's making the decision.
Since I'm closer, I'll go first and then pass it down that way. Joe, I kind of view it as in the same way, like as there's a lot of data that the operators get, right? And I just feel like that AI as a way to kind of like absorb and ingest and process and sort through it and help provide them with tools that they can use to make better, more effective decisions that, there might be some patterns there or some downstream consequences that, are not immediately obvious just to a human, but if you have an AI tool that can help to parse through all of that, it can help to make better decisions. So that's kind of where I'm hoping things go, but, we will see.
And my comment, I think, is extreme events is where we really still need that human, like we've talked about a little bit. AI will give you improvements in kind of the normal scenarios, but if it's a situation that isn't in the historical data set, that's where I think we really fall back to, a human with experience being able to handle that situation a little bit better. So I don't see us, fully getting away from having that, kind of last check on the manual side, human side. But right, I do see, improvements using AI in your kind of more standard scenarios.
Thank you all.
Julian, AI solar forecasting out of Australia. A, a closely related question. We talked about black boxes of forecasting. When you take behind the meter solar forecasting, there are several ways you can do that. And I'm curious, those of you using those forecasts, how important is it to look into the black box and understand it and have some understanding of why these forecasts are the way they are? And maybe it depends on what's being forecasted. Maybe that's more important for behind the meter solar, not as much for wind. I don't know. But how important, how much does a user of the forecast care about understanding the way the forecast works?
From our perspective, it's almost being able to understand why a forecast missed. I think that's something that you lose when it is a black box and you don't have any real information on how it's being calculated. You can't explain, why it was off a certain day. So that's something that I find helpful in understanding the components that are going into the forecast, is being able to explain what went wrong, and in the future, that theme of understanding your risk.
I could maybe add as like a general thing across conversation with different utilities where there can be some skepticism. I think people are getting much more comfortable with these, that it being a black box isn't really for the end users that big of a deal anymore. But there is a sort of desire that there is someone that knows something that I can go to and ask. And to Rebecca's point of like, why did it go wrong? And what does that mean about the future? I think that's maybe more important. And I also have this sort of view of like, everyone still treats it as like, if it's machine or AI, it's a black box, there's nothing we can do. There is a lot of advancement in that to understand, and like, why is it forecasting a certain way and what's happening? But I think people are much more comfortable. And the reality is, even without those, you still have a lot of end users where it's like, yeah, I'm not a meteorologist. I don't understand this. You told me the solar's doing this, the weather's doing that. Like, I'm expecting you to understand why. So my sort of collaborative experience is people aren't as worried about that.
From the other side, from the forecast vendor perspective, I can say that our customers are not shy about, asking when there's a high forecast error and what caused it and things like that. But we have a team that can go and investigate and provide that explainability component, and it will help the customers to be better end users. It will also help us to see what sensitivities they have and where do we need to, improve things further for them. One concern is that, so right now our forecast system behind the scenes, there's a lot that goes into it, but the components are all pretty explainable once you get into it. If we on our side get to the point where we're doing mostly an AI black box on our side, we lose a lot of that explainability, both which hurts us, but then also hurts the end users, because then we can't give the real good explanation to them. And then it's like, how do we actually tune this? How do we improve this? What do we do from here? So I think it's a balancing act. If the end result is the best forecast possible and that's a black box, okay, there's some benefit there, but there's also some real good benefit to having that explainability component.
So I'm kind of looking at the time, and I wish we had another hour. But let's cut the questions off after the people who are still, and then we'll transition into a wrap up.
Jeff Chu from Deep Trend. So we are the newcomer forecasting. So number one, I want to thank you, EPRI. So this is great panels, David, Justin. So you guys, bring the industry together, did a, DOE forecasting competition. Really, for our newcomers, we the first time see this common ground, common matrix, everyone can participate. So I think that's a great job, David. Thank you for everything, Justin. So I want to make a second one that, when the William showed the data. Actually, I know who I am. So surprised me when you guys showed the ramps and our name is there, which is not the real name, is some name, so generic. But that is give you exactly what we talk about, a common ground, the matrix. So the Matthew mentioned about it, the Leah mentioned about, this is common ground. I think the industry can do a lot for those one. So user, vendor can come, same common ground to understand. I want to give you a thought, everyone bring the thought, because come from very different industry. come from battery. I'm a long time battery researcher for 20 years. So only last 10 years, I've shifted more, hoping university to commercialize. This is a forecasting technology now. But I wanted, because this is energy system integration group, right? Energy storage is a really hot topic today. Battery, particular batteries. But the battery is not as robust as like solar panels, like wind turbines. That battery degrade every day, every moment, which we know is chemistry based. So I want everyone think about bring the home, the food of soul. How this ESIG group can come to something similar, like the forecasting for the solar wind load has those well-defined matrices, or even we are still evolving, come to understand how battery, how storage can be evaluated. Of course, because we understand state of health. That's I want to give from you.
Yeah, no, it's a great point because I think we're going to see increasingly, I know we get a lot of questions of like EVs on the system and how do I forecast those and what is the data and what's considered data centers. We had some discussion today and across different timescales. And I think there's a lot of this where everyone's facing similar problems and maybe only has certain data experiences. And if we can bring those together, whether that is like, hey, let's have common benchmarks or it's just, let's discuss the problem. So we should write this down as topic for next year.
Yeah, I think, that's very interesting because the system, even we talk about lithium ion, not the same chemistry, but even the same chemistry, different manufacturer, different foreign factor will come into play.
Yeah.
So lots of things to talk about. I think that the topic, if ESIG can do something, add value, that can give us another 5-10 years to talk about.
Definitely a great topic
thank
for
you.
the future. Yeah, thanks,
good panel.
Justin Shoemaker, ISO New England. This is my first experience with ESIG. It will not be my last. I've had an amazing week this week. My question comes from an operations perspective. I spent my whole career in system operations, and it's an area where we're largely ignorant about the risk profile of the actions that we take. The very bedrock standard of reliability, the N-1 standard, is totally ignorant of the risk. And we say, anything is possible, so we need to be prepared for any of it. My question for you, I've heard a lot of the experts in forecasting this week talk about the quantification of risk, our new ability to quantify it, and asking what we need as operators to make better decisions with these tools. And my request to you is we need someone to help us quantify the risks that we already have been taking historically, so that we understand what risk profiles we've been living with all these years that we've been ignorant of, so that we can then figure out how to use those risk profiles to make better decisions going forward. And so I'm looking forward to hopefully next year hearing back from some folks that have done some work on quantifying the risk that we've already been taking for the last 50 years. Thank you.
Or we're going to make you the speaker because you asked the question that. Yeah. But yeah, it's a great topic. I just want to add that like these sort of topics of we move into this and understand we haven't been thinking about this. And I know I've had discussion with Brent and others of like giving that sort of visibility of like where you are and where can you go and what do all these compounding risks mean? Because maybe only we're thinking about solar, but what about wind? What about load? What about other things happening? So yeah, another great topic.
Okay, yeah. So just to kind of wrap things up, what we also wanted to ask this group and also put some thoughts into all of you. Debbie mentioned in the opening that this is, I think it was the 18th workshop, which means this workshop can now vote. And the question comes: are we ready to send this workshop off to college you know, and just good luck. We've taught you everything we can, and you know, it's you're all set. You're good. You know, we've had these communications for all these years. Or, you know, do we really need to, you know, expand things and continue, you know, what type of, so I want the group and Justin share some more thoughts too, if you have them, but want to try to hear some feedback from you all on how these parallel sessions work, what types of sessions could be more useful in the future, how do we sort of bridge things? Justin, any other thoughts?
Yeah,
on that?
just some quick thoughts. I mean, the conference has traditionally been called the Markets and Meteorology Conference, and this year we renamed it to Forecasting and Markets, I believe. You know, in this discussion here, it's been largely focused on forecasting and operations, but this morning we got into sort of the planning time frame of it. Is our focus changing? Do folks feel that the risk profile is changing towards so you know, is there more than just markets? Is it, you know, system operations and meteorology and markets, or just the nexus of meteorology in general with the grid? I think is kind of what we're looking to get feedback from everybody on.
Right. I mean, I think what I've heard a lot from the vendors this year is I really want to understand how the end user, you know, uses my forecast, what the acceptable error is, risk is, that kind of thing. So I think having both the, you know, developers and the very end users, which is in most cases system operations, interact and you know, discuss.
Are you asking us to vote? I vote we do this again. You vote we do this again? I think ESIG is awesome. I think the stuff that I learned last year is going to help Southern Company move some things forward that we need to. I think John talked last year about broadly in the group. I really championed what he said is he sees ESIG as like an orchestra and maybe everybody plays their instrument. Y'all remember that? And if we can play it together and maybe make the same sound and it sounds good, then we're doing the right thing. And if you think about renewables and the grid changing and reliability and trying to take risk, I think ESIG is fundamental in that, and then working together to actually achieve more than we could alone.
Yeah, I'll echo the first 2 points. I think this is essential. I don't think there's anything like this. I don't know how we could expand it because there's only so many people work in this area, but I think trying to find more opportunities to collaborate, maybe there's additional topics that need to be brought in, or thinking about, you know, when we talk forecasting, we tend to focus on operations. There are similar things going on in planning and thinking about that, or trying to have forecasting markets more tied together, but generally very positive. And if ESIG decides they don't want to do it, I think EPRI should do it, but I'm biased, so we should keep doing this somehow.
I'm incapable of providing an unbiased opinion here. This workshop is very dear to my heart. And even when I can't go and I recommend other people at my company or elsewhere to come here, I feel really strongly about that. I do think that, you know, to use your analogy, I think, you know, if this is like a younger person going off to college, I mean, maybe that's a good analogy because I've seen this workshop evolve considerably over the years, and I think it evolves in kind of step with how industry has changed. And right now there's such a significant amount of change going on that maybe there is, you know, just a bit of an identity crisis. And so let's wait a little bit, and maybe it's just like retooling and recalibrating its identity a bit, as is already has taken place over time, but maybe more so now it needs to happen.
Yeah, this is my first year here, so I was shocked when you said just send it off to college, because it's been super valuable for me. I can't tell you how many academic conferences I've been to recently where I just leave feeling like it's just missed the mark. Like it's not, they don't talk about the problems that I'm thinking about day to day and trying to solve. And that's what this forum has provided. And I think that's the intersection between the providers and the users that creates that.
So this is my first time back at this conference, and I think about like 6 or 7 years, and being here this year and being having the opportunity to be on this great panel here has really reminded me and reinforced about like how valuable bringing together this kind of group of people is. The first ESIG forecasting workshop that I attended, I think it was 2011. It was when it was in Albany, New York in the winter. Some of you may remember it. Some people got stuck in the Albany airport waiting to go home. But the conference was very eye-opening to me at that time early in my career. And it has grown, it has evolved. And we can put it up for a vote. I would venture to say that there might be nobody here who would vote to just kind of like send the conference off to college, but I think, yeah, just continuing it and expanding it, bringing together different people. We already have, I think, like 3 different ideas for panels or sessions for next year. So let's build upon that and let's make it happen.
Yeah, I'm going to very briefly take off my, and I want to make sure that you have time last time to say something, but I'm going to take off my chair hat and put on my panelist hat really briefly. This is my favorite conference of the year. So from ESIG point of view, well done ESIG for all the work that you do organizing this. I think it's really important. Where I feel I have a pretty strong feeling and agenda in my own mind is that we're getting to a point where penetration is high enough now, and John's indicated these cases where forecasting alone does not solve the problem. And there's a lot of meteorology that gets much deeper into the planning. And I think if we're going to do any evolution, that's where it needs to be. I'll leave it at that.
Yeah, just something very quick. Leah, as a recovering academic myself, I can't agree with you more. And I think one of the things that ESIG brings here, and I just want to leave this with everybody, where else can you go to a conference and bring together weather professionals, utility professionals, computational professionals, all in one area to actually work toward the same goal? When you go to academic conferences, they're living in these extreme silos. And I think that's what makes this particular workshop extremely valuable. So I just want to echo exactly what you said, Leah. We are at the cutting edge. No, we're not academics. No, we're not tenured or trying to just publish. We're just trying to move the ball forward for society. So I just want to leave it there. I just wanted to follow up on that. Thanks, Leah.
Yeah, my question wasn't meant to just get a pat on the back, but some good feedback. So thanks, everyone. I do want to let Debbie have the last word here before we go to lunch. Appreciate everyone's participation in the panel.
Sure, thanks so much. So first, I think we need to thank Erik, Justin, and the whole panel for a great closing plenary session. And I want to just thank all the speakers and all the session chairs this week. It's been a fabulous conference. I learned a lot. If you have ideas for future conferences, sessions, presentations, you should always just send them in to me or Ryan or any of us. And I especially want to thank, and I realize they're not here, but Ryan and Lacey and Brooke, the folks that have been running around with like the computers and the presentations, they make this workshop happen. So even though they're not here, please thank, oh, great, there's Ryan. All right, and thank you all for engaging, asking questions, just participating in the lively discussions. This wouldn't be this kind of event without all of you really participating and being part of this. So hopefully we see you next year. This conference is going to be, we're going to do this in Denver in June next year. So hopefully it's not as hot. Anyway, take care, safe travels back home. And those of you who are staying for the large loads workshop, that's going to start at 1:15. Is that right? Yeah, after lunch. All right, thank you.